Okay, these are the 4.9 notes. Make sure you have your 4.8 notes handy because we're going to be referencing them quite a bit. You've got 3 steps. Steps 1 and 2 you learned in lesson 4.8. So make sure you have those notes available. And then we're going to work on step 3 today. All right, so our first step is we're going to find the vertical asymptote. We do that by setting our denominator equal to 0. So I'm going to write vertical asymptote, VA. I'm going to take my denominator and set it equal to 0. Add 3 to get x equals 3. Now what I'm going to do is I'm actually going to graph that on my graph at 3. So here's 3, and I'm just going to draw a vertical line all the way up and down. So that's step number 1. Step number 2 is going to be to find the horizontal or oblique asymptote. So what I'm going to do is I'm going to look at the degree. This is a degree 1 and a degree 1. Again, we're talking about the exponents there. That would be same over same, which means that I'm going to divide the coefficients. The coefficients are going to be the 1 and the 1 in front, and 1 divided by 1 gets me 1. That's going to be my horizontal asymptote. So I'll go over to my graph, go up to 1, and draw a horizontal line. So those are the 2 things we learned yesterday. Now let's talk about part number 3, step 3. Pick a point on each side of the vertical asymptote and plot to draw your graph. All right, let me fill in my answers down here with what I got. So vertical asymptote is x equals 3. Horizontal asymptote, y equals 1. All right, and now we're ready to find where the graph actually is. So what we're going to do is I'm going to locate where the vertical asymptote line is. Here it's at 3. So I want to pick one number bigger and one number smaller, so something on each side of it. So visualize it like this. You've got 3 here for your vertical asymptote. You want to pick the smaller number and a bigger number. So for this problem, that means I'm going to pick 2 and 4, because 2 and 4 are on either side of 3. So I'm going to pick 2, and I'm going to pick 4. That's going to give me the x portion of my points. In order to find the y portion, I need to plug it in to find the y value. So what I'm going to do is I'm going to take this equation right here, and I'm going to plug in a 2 for both of those x's. 2 minus 5 over 2 minus 3. That gets me negative 3 over negative 1, which gets me positive 3. So when I plugged in a 2, I got an answer of 3, meaning my point is 2, 3. Do the same thing for the 4. Plug in a 4. That'll get me negative 1 over positive 1, which gets me negative 1. When I plugged in 4, I got negative 1, resulting in the point 4, negative 1. These 2 points I'm going to plot, and then I'm just going to kind of sketch out what it looks like. So the point 2, 3 would be right here. And the point 4, negative 1 would be right there. And if you remember back when we did our graphs, we had this one was called the reciprocal graph. This is very similar to it because it's got a fraction. So what you're going to do is you're going to get very close to your asymptote lines, go through the point, and then stay very close to your asymptote lines. Almost like you're tracing along the blue lines. Just like that. So what you see there in pink is the actual graph, and the blue lines are just there to guide us. Those are called your asymptote lines. All right, let's try example number 2. We'll start again with our asymptote lines. Step 1 is finding the vertical asymptote. I'm going to set my denominator equal to 0. Add 4 to get us an answer of x equals 4. And I'll make sure I plot that, draw that at the point 4. right through here. There's your vertical asymptote, x equals 4. Step number 2 says that I'm going to need to find the horizontal or oblique asymptote and draw the line. So in order to do that, I have to find the degrees. This is a degree 0 because I don't see any x's, 0 x's. In the denominator, I have a degree 1, x to the first power. This represents a low over high. I look at my chart for my 4.8 notes, and I realize that a low over high is automatically going to get me an answer of y equals 0. So I'm going to draw my line here at y equals 0. So then I'm going to identify again where my vertical asymptote is. My vertical asymptote is at 4. So I need to think about the number 4 here on a number line. What would be to the left of it? What would be to the right of it? 3 and 1 bigger, 5. So 3 and 5 are going to be the numbers that I'm going to plug in. We choose these numbers because it's almost always going to get us whole number answers, which is going to be very easy for us to graph. You can technically choose any number, but these are going to be nice whole numbers. Then you go back to your original equation, and you're going to plug in a 3 and a 5. We'll plug in the 3 first. There's only one place to plug in the 3 in for the x. Got an answer of -3. And then we'll go ahead and plug in the 5. Again, only one place to plug in the 5 this time. And I get +3. These are the 2 points I'll graph. +3, -3 would put me right here. And 5, 3 put me right there. And again, you're going to make this look like that reciprocal graph. You're just going to kind of trace along the blue, staying close to the blue throughout the entire graph here, just like that. All right, for the next one, problem number 3, same setup as before. We're going to find the vertical asymptote. So we're going to set our denominator equal to 0. Well, there's nothing to do there, so that means that's my answer, x equals 0. I'm going to draw a vertical line at the 0, so right along here. For the next part, I'm going to find my degrees. This is a degree 2 because of the exponent of 2, and a degree 1 because of the exponent of 1. That represents a high over low. Again, if you reference your 4.8 notes, that's a high over low. High over low tells us we have to do long division. So I'm going to set up my long division problem. I'm going to go ahead and put in a 0x here. Since there's no x, it got skipped. I'm just going to make sure I have that. All right. And then I start doing my long division. So you would ask yourself, x times what would get you x squared? That would be x. Then you multiply. Then you change the sign. And then you drop down. X times what will make 0x? That'll be 0. And remember, as soon as you get a number up at the top here, you can stop early. So we're going to get an answer of y equals x plus 0, which you could also just write as y equals x. I'm actually going to write this as y equals 1 over 1x, my slope, plus 0, which is representing my y-intercept. So this is a regular line, diagonal line, starting at 0 and going up 1 over 1, up 1 over 1, up 1 over 1. All right. So there we have our two asymptote lines. The next thing we're going to do is go on either side of our vertical asymptote. So we're thinking about this 0 right here. That 0, if I go one bigger, it's 1. If I go one smaller, it's -1. So those are the numbers that I'm going to plug in to my equation up at the top here. All right. So I'm going to start by plugging in a -1. Then I'll plug in the positive 1. When I plug in a -1, I get -1 squared. The parentheses are important. -1 over a -1. -1 squared gets me +1. 1 minus 1 is 0. And 0 divided by anything still gets me 0. I'm going to do the same thing for a +1. Again, parentheses are important. It's 1 minus 1. And I'll subtract and divide to again get 0. So then I can plot the 2 points. -1, 0 would be right here. And +1, 0 would be right here. They're very close to those asymptote lines. So again, we're just going to trace up along the blue, and again, and then here just along the blue, and straight up. Right, and my last one, example number 4. We'll start by doing our vertical asymptote. Set the denominator equal to 0, and solve. For our horizontal oblique, reference your 4.8 notes. This is again a degree 2 over a degree 1. When we talk about degrees, we're talking about the exponents, which means this is a high over low, which means we have to do long division. And notice nothing got skipped over here, so I don't have to insert a 0 for anything. X times what gets me x squared? That would be x. Then I multiply. And I'll need to change my signs. Cancel. Bring this down to make 1x plus 4. X times what makes 1x? That would be 1. And remember, as soon as I get a number at the top, I can stop early. I don't have to finish the whole problem. Y equals x plus 1. And because it's got an x and a y in it, that's going to be an oblique asymptote. More of like a slope-intercept form. All right, let's graph the vertical asymptote first. I'm going to go over to -2, and I'm just going to draw a vertical line. For the oblique asymptote, I'm going to start with my 1, up 1, and then I'm just going to do a slope of 1. So think about that as 1 over 1. Rise over run, rise over run, rise over run. And continue the opposite direction. Now that you have your asymptote lines drawn, we are actually going to plug in numbers on either side. So here I have a -2. So I'm going to plug in numbers on either side of -2, meaning -3 and -1. These are the two numbers I'm going to have to plug in. This one's going to be a little bit more difficult because you have so many x's in this problem that your numbers are going to have to go in for. So very carefully, we're plugging it in for each of our x's. I'm going to start with a -3. So -3 squared plus 3 times my x, -3, plus 4, over my x, -3, plus 2. That is me plugging in a -3 for every x that I see. Then we're just going to simplify. Oops. You can type this into your calculator in the numerator if you want. Type that all in. But I'm getting 9 plus -9 plus 4, which is just going to get me 4. And in my denominator, -3 plus 2 is -1, resulting in an answer of -4. Again, if you want to type this into your calculator, you would do the top part in your calculator first, and then the denominator, and then divide them out. Don't try to type it all in at once. It might be too much. We're going to do the same thing with the -1. Again, you can type the entire numerator into your calculator, or just very carefully do the math. That would be 1 plus -3 plus 4, which would give me 2. -1 plus 2 is 1, and I divide that out to get 2. So when I plugged in a -3, I got an answer of -4. When I plugged in -1, I got an answer of +2. And just a little hint here, you should always have on these graphs your two graphs in opposite corners of each other. So as soon as I do the -3, -4, here in this little corner, I know the other one should be up here in this top corner here. So -1, 2. See, they end up falling in opposite corners of each other all the time. And just kind of trace it along that blue line. And there's your final answer for your graph.